We're going to finish this up the first part of class, so let's just go ahead and kind of start over again on this first thing. So what I had you guys do on this, if you have a equation with logarithms in it, you always want your logarithm to be isolated, which it is. Okay, there's nothing in front of the log. So what you do is you write it in exponential form. Okay, and ultimately that's what you end up doing on most of these problems anyway. So if you do exponential form, you say 2 to the third is equal to x plus 3. So we did that. That's going to be 8 equals x plus 3. Then you subtract 3 from both sides. So you get x equals 8 minus 3. So x is equal to 5. So you already did that problem. And if you want to really get good with your exponent rules and logarithms, you got to learn how to check these things. So I don't remember if I went through the checking. So you're just going to replace the answer back in for x. So you'd have log base 2 of 5 plus 3. That's log base 2 of 8. Now my hope is that my students can look at log base 2 of 8 and like within a snap of a finger can tell me the answer. Can you? It's 3. Good. Because what is it? It's 2 to the third equals 8. Okay, good. Remember, the answer to a logarithm is an exponent. So it works out the way it's supposed to. 2 to the third is equal to 8. So that's the right answer. Okay, does that make sense? That's the simplest type of log equation you can do. Okay, now what we did on this one is, what we said is like if you had an equation, like if you had x squared or just some equation, x to the third equals 10 or something like that, you can actually take the log of both sides, but you can also do the opposite. You can take the logs off. Now, you're not canceling logs. I always see students on this problem do the problem this way, and this is totally wrong. You don't go through and cancel logs out. The log and its argument, which is what's in the parentheses, they are together. You can't separate them. They're inseparable. So what you're really doing is you are really undoing that log. You're taking the log off. You're not canceling it. You're taking it off. So what you have is x plus 3 equals 5x minus 2, and then that's a real simple equation to solve, isn't it? Okay. So I'm going to just kind of rearrange in my head. I've got 5x here. I'm going to move the x there. So that's going to be 5x minus 3 there. Then I'm going to leave the 3. And then I'm going to move the 2 like that. So I have, when I have that, I've got 5 is equal. Hold on. What in the world am I doing here? Okay, hold on. That's an x. Okay, so what I need to be doing is I need to move the x to that side like that. So now I have 4x equals 5, and then I divide by 4. Okay, so we've already done those two problems. We did those at the end of last class. Okay, so do you guys got any questions about those? Okay, now they're going to get a little bit more complicated, but you're still going to kind of do the same idea. So let's start here with number 3. This is where we left off. So we learned all those properties of logs last class period, so you got to remember some stuff. So let me see if you guys remember this or not. So we spent a bunch of time on this. Like if you had a log base b of m plus log base b of n, how did we put together 2 logs added into 1 log? Go ahead and multiply, a product. Remember, we had this property that says this would be equal to the log base b of m times n, like that. So that's what you're going to do. You're going to put those 2 logs together, so go ahead and do that now. Write that as log base 3 of x times x minus 24. Okay, then that's going to be equal to 4 like that. Okay, everybody got that? That's what we did last time. Now, what you want to do now is you're ready to write this in exponential form. So you need to know what I'm talking about. Of course, you did that on the quiz today. So what's the base of this logarithm? 3 to what power? 4, okay, is equal to what you're left over with was x times x minus 24 like that. Okay, so that's how you start that problem. Now you've got a quadratic equation, which we've solved many, many times this semester. So you want to work out 3 to the 4th, which is 81. Okay, and then we're going to just bring this down, and we're going to go ahead and do a distributive property. So that's going to be x to the 2nd minus 24x. Okay, any questions so far? Okay, what do we have? We have a quadratic equation. How do you know it's a second power? So what do I need to do? Got to get one side to 0, and then hopefully we can factor this, right? Okay, So let's do that. So go ahead and just move the 81 over like that. So you got one side equals 0. So you have x squared minus 24x minus 81 like that then. All right, so we're going to try to factor that if we can. I think this factors. The possibilities are you could have like 9 times 9. You could have 81 divides by 3. It goes in 27 times. What do you want me to use, 9 and 9 or 3 and 27? Yeah, okay, because they add up to 24, okay? You don't always see that immediately, but sometimes you have to play with it a little bit until you find that. So what we're going to do is, this is 0. I'm going to draw 2 parentheses, so we're going to have x and x. We're going to have 27 there, and we're going to have a 3 there. If you struggle getting these signs figured out, and many students do this. What are you trying to do with 27 and 3? Make it add to negative 24, right? So what is what? What's the sign on the 27? Yeah, that's negative. That's positive like that. If you do it that way, I mean, you're not going to mess up. So double check your signs when you do that then, okay? All right, now what we have to do, now there's a couple other things we have to do. So what are the 2 answers to this equation anyway, now that we have got it factored? 27 and negative 3. Now I stress those are the potential answers, okay? So what we're going to have is, let's write down that it looks like maybe we have x is 27 and x is negative 3. Now watch this part carefully, because this is a lot of times where students don't pay attention. You got to check your answer. So what I'm going to do is I'm going to start by plugging in the 27. And please write this on your notes. You need to know how to check these things. So we're going to go back to the beginning, and everywhere you see an x, you're going to put in a 27. Now we're not going to get the calculator out because we don't need to. So we're going to do log base 3 of 27 plus log base 3 of 27 minus 4. And we're going to work that out, and we're going to see if we get a 4. Okay, so let's see what happens. This is log base 3, 27. This is log base 3 of 3. That needs to be a 24 there, sorry. Okay, all right. So that's going to be log base 3 of 3. Okay, I need to get you guys doing these kind of logarithms extremely fast in your head. What is the log base 3 of 27? 3, because 3 to the third is 27. Good. What is the log base 3 of 3? 1. Good. 3 plus 1 is 4. That checks, doesn't it? So without a doubt, 27 is an answer to the problem. We know that for a fact. But watch what happens when I plug in the negative 3. Now what I'm going to do on this is just kind of start over again. And I'm going to write down log base 3 of negative 3 plus, get over there, calculator. So I'm going to do log base 3 of negative 3 minus 24. All right, and I'll see if you got this down yet. This is something you got to know. Do you know anything about the log of a negative number? Cannot do it. There is no such thing as a log of a negative number. That's something you need to study and make sure you get down, because what does this mean? It really means 3 to what power is negative 3? That doesn't make any sense. You can't take 3 to a power and get negative 3. If you take 3 to any power, you get a positive number. So guess what? That is not the answer. That's called an extraneous solution. We've seen that before. So the only answer to this problem is 27. So we just write the answer in a set solution as like 27 like that then. Okay. Beautiful test question, by the way. It's an absolutely beautiful test question because it tests so many things. So many things. So if you guys understand what I did on that, okay. All right, study that, okay. All right, let's go down and let's do this next one here, and then I'll let you guys take a little time to work a few problems out and see if you know what you're doing. Okay, now what you're going to do on this one is, if you have logs on different sides of the equation, one thing that you usually want to try to do is get all your logs on one side. So what I'm going to do is leave this log where it is, and I'm going to take this one, and I'm going to move it. Okay, so let's just bring down that log base 2 of x plus 1. Bring it down. Now I'm going to move this entire log. So you're really subtracting, right? So that's going to change that to minus log base 2 of x minus 2, and then leave the 3 where it is. Okay, you guys have been doing that all semester, just kind of rearranging both sides, right? Okay, now you got to know something about what I taught you in the last class, okay? If you have a log of a number minus a log of another number, how did we learn how to put that into one log? Do you remember? Good, dividing, okay, a fraction, outstanding, what a class. Okay, so we got m over n like that. So we're going to put this together like this. We say log base 2 x plus 1 over x minus 2 is equal to 3, like that. Okay, does that look okay to everybody? That's one of the reasons we learn those properties, because you got to do that. Now, what we're ready to do is write this in exponential form. Okay, so what is the base? 2. What is that raised to? What power? 3. Good. And then that's equal to x plus 1 over x minus 2, like that. Okay? Now we're ready to solve that equation, and that is a kind of equation we've learned how to do this semester. So 2 to the third is 8, and I'm going to show you how to finish this up like this. So what we have is we have an equation that's got fractions in it, right? So what do you try to do if your equation has fractions in it? You get rid of them, right? Okay, so what are you going to multiply by? X minus 2. Good. Okay, so we're going to do that. So we're going to multiply this by x minus 2 over 1. That'll cancel that out. And then you got to do that. Now you have a real standard equation that everybody will be able to do just fine. Okay, so let's move this over here. What I'm going to have is 8x minus 16. And then this side is going to be x plus 1. Solve the equation. You can rearrange in your head like we've been doing all semester. So we just kind of move that. Move the 16, so you would have 8x minus x equals 1 plus 16. So that's 7x equals 17. And divide by 7. And then that should be the answer of this problem. So I'm just going to write that as final answer as 17 over 7. I'll talk about the checking on this too. I'm not going to go through all the details of the checking, but listen to this carefully, because this is super important. Like the last problem, we had to throw the negative answer out because you ended up taking a log of a negative number. The thing that you have to look for when you check is if this is happening. Okay? So if you plugged this answer in, just kind of do this in your head. If you did 17 over 7 plus 1, would that be positive or negative? That's okay. What if we did and plugged it in here? 17 over 7 is like what? 2 and 3/7. So it's 2 and 3/7 minus 2, positive or negative? So it's okay. You see what I mean? Now, you don't have to go through the details of that, but like if this answer was 1, then you would have 1 minus 2 is negative. Guess what you would do? You'd throw it out. That's what you got to do. You cannot take a log of 0 or a negative number. Okay? Got it? Okay, let's find out. All right, you guys work these 3 out here. You can work together a little bit if you want to and see. Be sure you check. I mean, at least make sure that you don't have any solutions you got to throw out. You probably will have a few extraneous solutions. Okay, I'm going to go ahead and run through that. If you're in the middle of that last one or something, you can go ahead and finish it up. So we just want to make sure that you can handle all these different types. So this one you should have just started by saying 3 to the second equals x minus 1. That one's already it's ready to change into exponential form, so you'd have 9 equals x minus 1. So hopefully you guys got the answer of 10, did you? Yeah. Okay, very good. You got x equals 10. If you didn't check it, at least write this on your paper, because this is one of the ways that helps students understand this better. Is, you're basically just taking that 10 and you're plugging it in right there, of course. So if you work this out, it's real easy to check this problem. This is just saying log base 3 of 9. What is that? Remember, you want to be boom, boom on these. 2. Very good, right? 3 to the second is 2. So that means that one checks out, doesn't it? That's it. It's the right answer. Do that. Okay, the next one. What did you do on this problem? Take the logs off, okay? The opposite of taking a log of both sides is taking them off. So you just say 4x plus 3 is equal to 4x plus 7. Ooh, I gave you a problem. I'm trying to trick you here. All right, what I'm going to do is I'm going to do this. I'm going to move all the x's to this side. So I'm going to bring that down. That one's going to be minus 4x. I'm going to leave the 7 where it is. I'm going to move the 3 there so I get this. So what you have is 0 equals 4. What does that tell you?
No solution.
No solution. Very good. Okay, we've seen that before. So anytime you're solving any type of equation and the variables cancel out and you get a statement that's false, then that means that the answer is no solution. So you can write it that way. Or a lot of times you just put this thing we call the empty set symbol like that. So there is no solution to that particular problem. Okay? All right, and then the last one, what you got to do on this one is you got to put these two logs together into one log. How did you do that? You multiply, right. Okay, we have the property that says the sum of the logs is just one log of the product of those two things like that. So that's how you should have started the problem. Now you're writing exponential forms. You're going to have 4 to the second equals x plus 4 times x minus 2, like this. Okay, so I'll move over here. You got 4 to the second is 16. You should have FOILed this out, so you would have x to the second minus 2x plus 4x, and then minus 8. If you can do that whole thing in your head, that's fine with me. So you have 16 equals x squared plus 2x minus 8. What kind of equation do you have? Quadratic. So what do you got to do? One side equals 0, then factor. Good. So we're going to just move the 16 over this side, or you can do this and write the step this way if you want to. So that's 0 equals x to the second plus 2x minus 24, like that. Okay? Now, let's see if this one factors. So, what are two numbers that multiply to give 24 that add up to 2? 4 and 6. Good. So, we're going to say, here we're going to say x and x here, 6 and 4 there. You need to have a plus 6 and a minus 4. So, the two potential answers are negative 6 and positive 4. Okay, so before we write this answer, you need to at least look at this. This is at a minimum what you got to look at. You got to look at those two things. Those are things that are called the argument. Okay, if you plugged in, let's start with the 4. If you plugged a 4 in, 4 plus 4 is 8. That's okay. You can have a log of a positive number. How about 4 minus 2? That's good. That's positive, so that's an answer. Now look at the negative 6. If you replace that with negative 6, what kind of number are you going to get there? Negative. So that one must be thrown out. It's not because it's a negative 6. It's because that thing is going to become negative. A lot of times students, they say, oh, I got a negative answer, I throw it out. That is not correct. Negative answers can be okay, but what's not okay is that you take a log of a negative number. Does that make sense? Okay, throw it out. Your answer is 4. Okay, that's the one that I like. That's kind of a nice test problem because it tests a lot of things. Okay, all right, any questions about anything? No? Yes? Okay, very good. We're going to go to the next thing where we're going to solve what we call an exponential equation. And we're going to do this in 2 stages. Okay, the 2 stages that we're going to look at here are going to be the bases are, we can make the bases the same. So the base on here is 64 and then 4. There is a connection between 4 and 64. So what you want to kind of look for on this is 4 can be written as 2 to the second. 64, you have to work with it a little bit. And if you don't see this, you can do factor trees like 64 is 8 times 8. 8 is really 2 times 2 times 2. So let's see, if you look at this, we would have 1, 2, 3, 4, 5, 6 2s. So that means that 64 is 2 to the 6th. Okay? And you can play with your calculator a little bit on that too, but you know, the ideal way is just kind of figure out they're both are powers of 2. They're also both powers of 4, and you could work at it that way if you wanted to. Okay? So you could also say, well, just leave the 4 alone, and then 64 is 4 to the 3rd, right? So you can work with it either way. I think it's probably easier to just work with a 4. So what I'm going to have you do is just bring down the 4 to the x, and we're going to change 64 to 4 to the third. Now, if you've caught on to what I've already taught you, you could tell me the answer to this problem real easily. The bases are the same, so what's x have to be? 3. That's staring you right in the face, right? So the answer to this problem is x equals 3. Now, some of you may be saying, well, gosh, I knew that before the teacher even started talking. You may have. 4 to the third is 64. If you see that, that's fine. What I'm trying to do is prepare you really for the next problem, which is a lot harder to do in your head. So the checking on this just goes 4 to the third is 64, and you know that's right. Okay? So the idea is I was trying to rewrite the 64 so it has the same base that 4 does. Okay, now we're going to do this next problem the same way. All right, so this is already just has a base of 2. How about 8? Can you write 8 as a power of 2? Yeah, it's 2 to the what? 2 to the third. So that's how you're going to start the problem. You're going to start by just bring this down as it is. You don't really need those parentheses there, so you do that. Then you write that as 2 to the third. Okay? Now again, this is what you want to catch on to. The bases are the same, so what conclusion do you make about the exponents? They are the same also, right? So what you do is you write down 1 plus 2x is equal to 3, then you solve that equation, okay? So what you're going to do is you can subtract 1 from both sides. That will give 2x equals 2. You divide by 2, so that will give an answer of x equals 1, okay? Does that look okay? Okay, these get a little harder, but this was kind of a good starting point. Then when you check this, you would just say 2 to the 1 plus 2 times 1, because I'm plugging that in right there. So that is 2 to the 1 plus 2, that's 2 to the third, which is equal to 8, and that's what it's supposed to be, right? So that's why it's the answer. So you want to kind of go through on these equations and verify that you have a right answer. Any questions so far? Okay. All right, this next one's a little harder. But it's got the same idea. It's all based on the same idea. All right, the first thing is, again, you're looking for this. You want the bases to be the same. And if those bases are the same, then so are the exponents. So you got to figure out 256, could I possibly write that as a power of 4? If you don't know that in your head, I'm not sure I know it in my head, I think it's 4 to the fourth, but you could kind of experiment on your calculator if you wanted to. So I know 4 to the third is 64, so if I go 4 to the fourth, that's 256, okay? So it's the same principle. Try to make that connection. So let's start by writing down 4 to the 5 plus 3x equals 1 over 4 to the fourth, like that. Okay. What's up?
Nothing.
Oh, you okay? All right. Okay. Now, I got to do something with this 4 to the fourth. What I need to do is I need to bring it to the top so that I have 4 to a power equals 4 to a power. When you bring that 4 to the fourth to the top, what do you get? 4 to the negative 4, right? The exponent changes. So you want to write the next step as 4 to the 5 plus 3x is equal to 4 to the negative fourth, like that. Okay? Now, it's exactly the same principle. Okay? I keep asking this because you have to get this in your mind. If the bases are the same, what are the exponents? They are the same. Okay? That's the whole point behind what we're trying to do here, is get that kind of rewritten that way. So now it's pretty easy to finish. You just say 5 plus 3x equals negative 4, like this, and then subtract. You can solve that equation. Once you get down to this point, it'll be easy for you to finish up. So you get 3x equals negative 9. Then you can divide by 3, so you get x is equal to negative 3, like that would be an answer. Okay? All right, now let me show you kind of how you would check this, because I like students to know how to do this. I'm going to replace x with negative 3. It's actually very easy to check the answer to this problem. Just plug in your answer. So what you're going to have is 4 to the 5 minus 9. That's 4 to the negative fourth. But what is 4 to the negative fourth? It's 1 over 4 to the fourth, right? And 1 over 4 to the fourth is 256, right? Okay, you guys see what I'm doing? Okay. So you can plug that in. You don't have to touch your calculator. You just got to know doing the arithmetic that 4 to the negative fourth is going to give that ultimately, right? Okay, you guys got any questions? Okay. You guys look like you have spring fever. Is it nice outside?
Yes.
I think it's supposed to snow this weekend is what I saw. Yeah, like 3 days in a row.
Yeah.
Like a slushy, sloppy snow. So, yeah, that's the way it is in April. Okay, you guys go ahead and try these problems. Number 11. Do you guys know what the answer to number 11 is? Okay. Let me give you a different problem instead. Okay, let me give you 3 to the x equals 243. Same idea. That one's kind of one you can actually play with your calculator a little bit if you need to, but the main one I want you to know how to do is that number 12. Did you figure out number 11? 5, okay. 3 to the 5th is 243. That one you can play with your calculator a little bit on. And again, since the bases are the same, so are the exponents. So that one would be x equals 5, okay. And then this next one you have 2 to the 7 minus 3x. You want to write the 4 as 2 to the second. That's what you should have done. And then you should have moved the 2 to the second up to the top. So you would get 2 to the 7 minus 3x equals 2 to the negative 2. Then you're allowed now to set the exponents equal to each other. And once you get to that point, you should be in good shape. All right, so we just do this. That's going to be negative 3x equals negative 9. Divide by negative 3. Hopefully you got x equals 3. Does that look good? Okay. So that's kind of preparing you for the next thing. You guys got any questions about that? Okay, all right. So let's look at now, let's go down to this number 13. Now number 13 looks like the problems you just did, but the thing is, if you didn't have a calculator, you would struggle doing this one because you can't write 19 as 3 to a power. Okay, you could, but it would be a crazy decimal. It'd be like 3 to the 2 point something. Okay, so what you have to do on this, and this is going to be kind of new to a lot of you on this, is one of the reasons, many reasons we studied logarithms a little bit, is so that you can solve equations like this. You can't really solve this equation unless you know something about a logarithm. So one of the things you want to do is you want this, whatever is being raised to a power, you want it to have nothing in front of it. There's nothing in front of the 3. You wouldn't want to have something like that. Okay, you would want to get this thing isolated by itself. And it already is isolated, so what you're going to do is you're going to take the logarithm of both sides. And you either want to use, you can do the log, or you can use the ln, because those are the two things your calculator does. Okay, take your pick. It'll give the same answer anyway. So let's work with the ln on this problem. Okay, so let's just take the ln of both sides. You want to go ahead and start that way. Okay, so we have this. Now we got to see if we remember what I taught you last time or not. I'm sure you did. Let me ask you that. Okay, we learned this property. If you had the log base b of x to the p power, there was something I said you could do with that p. Do you remember? You bring it down in front. Good. Okay, what a good class. So we can bring that down, okay, like that. That's what we learned. So we're going to do exactly the same thing here. We're going to bring that down. So you're going to write x minus 1. And notice I'm writing that in parentheses. If you don't, you're wrong, because that's going to be multiplied by the ln3 like that. Okay, so we got that. Now what we got to do is it's like solving any other equation. You don't get your calculator on this problem until the very end. What you want to do is you want to get x by itself. So you can get rid of this ln of 3. ln of 3 is a number, so how do you get rid of it? You divide, okay? It's multiplied, right? So you divide, okay? So what you're going to do is you're going to divide both sides of this equation by ln of 3. Okay, like that. Well, that's going to cross that out, and that's going to leave you x minus 1 equals ln 19 over ln 3. Okay, like that. Now, while I'm thinking of this, because I see this with a lot of students lots of times, this is totally wrong. Please don't do this. LNs are not, by themselves, are not numbers. Okay, they are married to the argument. ln 19 is inseparable. You cannot do a thing with that. And you cannot reduce 19 over 3 anyway. You can't do that. Okay, so what you have to do on this is just add 1 to both sides, so you get this final exact answer. X equals 1 plus ln 19 over ln 3. That is the exact answer to that problem. Now, we are going to get our calculator to get an approximate answer, but that's the exact answer. When you have exponential equations, you end up having exact answers that have logarithms in it. Does that make sense? Okay. Now, get your calculator out and do this with me. Let's get the answer and let's see if it's right. So we'd just do this. We'd do 1 plus ln of 19. You'd have to close the parentheses and then divide by ln of 3, close parentheses like that, and then round that off. So we'll just round that to like 2 decimal places is what the problem says. So we'll say x is approximately 3.68, like that then. So that would be your final answer. Now, another thing that you want to learn how to do is you want to learn how to take an equation like this and check your answer on your calculator. So I'm going to replace that x with 3.68. You check on your calculator like this. Okay, so what you end up doing is you go like this. You go 3 raised to, then you plug in the 3.68. You got to put that in a parenthesis. 3.68 minus 1, like that. Again, so I'm plugging in. Now when I press equals, I hope I get 19 or something very, very close. Indeed I do, okay? So that's the idea, okay? Now one thing I want to mention about this, you'll see this a little bit at the second part of class today, is like if you were into business and economics, there's all kinds of formulas in economics that have exponential equations, so this is done all the time. You know, it's the standard method of solving exponential equations. Okay, so let's go to this next page here, and let's look at a couple of things on the next page then. Okay, I'm going to do one of these, and I'll get you guys to do a couple of those, and then we'll do our break, and that'll finish us up on that. Okay, now this one is another exponential equation. This time, though, it has an e in it. And again, with this one, since it's an e, now what you're going to have to do is take the logarithm of both sides of the equation, and it's better to use ln. Okay, you could use log, but since that's an e, it's best to take the log of both sides this way. So you're going to do this the same way. You're going to do the ln of both sides of that equation. Okay, and that's how you always want to start that. All right, now here's the key. What are you allowed to do with the x plus 3? There you go, bring it down. So do that. So what you're going to have is x plus 3 times the ln of e is equal to the ln of 6, like that. You don't have to have the parentheses around the 6 there. Now, you don't really need to go to your calculator on this, because this is something I want you to know. You can do the ln of e without a calculator, because ln just means log base e, like that. So all this problem is saying is e to what power is equal to e. So what is that? 1. The ln of e is 1. Okay, so we're just going to replace that with 1. So you have x plus 3 times 1 equals ln of 6. Okay? You don't want to have to rely on your calculator to do ln of e. That's 1. So what you're going to have is x plus 3 on the left side equals ln of 6. And then what do you do to finish? Move the 3, right? Subtract 3, get x by itself. Okay? Just do that in your head. So you would be better off if you wrote it this way, negative 3 plus ln 6, and that's your exact answer. I prefer you write it that way instead of ln 6 minus 3, because a lot of times students think that the minus 3 is a part of the logarithm, and it isn't, so it's better to do it that way. Then we just take the calculator, and then again we get a a decimal answer on this then, okay? So if I do that, I'm going to have, just do -3 plus ln of 6, round it to 2 decimals, so we get x is approximately equal to -1.21. And let me show you how to check this one on the calculator also, because we hadn't done this yet on an E, I don't think. So on a TI, notice on your ln key, above it in yellow is an e to the x. So what you can do is you can go second ln, and out will come e to a power. So if you just put in -1.21, like this, and then plus 3, that's what we're trying to check, is that e to that power is going to be 6. So if I do that, we should be pretty close. Okay? Right? See what I mean? You can check these, every one of them. Even if they're decimal answers, you can check them. Okay? All right, so once you guys go ahead and do the next two, you'll need your calculator, because I do want you to get just a decimal answer. You can round to 2 places like I did. These are pretty similar to the ones I did. And we'll see how those go. Then we'll do our break here. All right, so the first one, now it doesn't matter whether you do log of both sides or ln. It's up to you. I'm going to do log just because I haven't done it yet. I did the ln on the other 2 problems. I don't care. If you do it this way, it works out just fine. So I'm going to do it this way. Right? So that means what I'm going to do is, of course, I can bring the exponent down in front. So when I do that, I'm going to have 2x minus 1 times the log of 2 equals the log of 10. All right? How do I get rid of log 2? I don't want it to be there, so what do? Good, I divide it. Okay, so I divide by log 2, divide by log 2. So I cancel my logs out, yes or no? No, don't dare do that. I see that with my calculus 3 students still. Don't do it. It's ridiculous. So what you have is 2x minus 1 equals log 10 over log 2. Leave it alone. You can't do anything with that. Now what you want to do here is you want to add 1 to both sides. Just move it so that you would have 2x equals 1 plus log 10 over log 2, like that, and then divide by 2. Now probably a lot of you, if you were doing this, would probably do it this way. There's a way I would prefer you not to do it that way and get this messy answer. What I would prefer you do on this is this. When you divide by 2, isn't that the same as multiplying by a half? Right? Okay, so those things cross out. So the best way to write the exact answer would be like this. Now you could distribute it, but you don't have to. I'm just going to write this as 1/2 times 1 plus log 10 over log 2, like that. That's the exact answer. Then you can go to your calculator and put that in exactly the way it is if you want to. And you could also just distribute this, so you would get 1/2 times 1 is 1/2, and then you just say 1/2 times log 10 over log 2. It doesn't matter which way you write that. Now when you do this on a calculator, this right here to me is the best way to write the exact answer, is like this. So if I do that on a calculator, I'm just going to go, well, 1/2 is 0.5. I'm just going to use 0.5 there. Then parentheses 1 plus log 10. And you could also use ln. It doesn't matter. Okay, divide by log 2, like that. And then that would approximate your answer on that. Okay, so what I'd end up having on here, where did my calculator go? God, this thing just, I don't know about this. Okay, 2.16. Okay, it'd be approximately the answer on that problem there, right? So we'll say that we have approximately 2.16 as the answer of the problem. Okay, is there any part of that you don't understand? Including that weird answer. Okay, because that's the exact answer. That's the way I want the exact answer written. Okay, let's do this next one here to finish up. Okay, so this time I'm going to do the ln of both sides. Do you know why I'm doing the ln of both sides instead of the log? because there's an e. It's better to do it this way. You don't have to, but it's better. You want to learn to do that. If that base is e, use ln. So bring that down. That's going to be 2x times ln e equals ln 7. What did we say ln e was a minute ago? 1. So what we have is we have 2x times 1 equals ln 7. So that's going to be 2x equals ln 7. Then you can divide by 2. So your exact answer is x equals ln 7 over 2. And you can't do anything with that. You can't do 7 over 2 because the 2 doesn't have a log in it or anything. So you can't do anything with that. So then you just go directly to your calculator and you go ln 7, close parentheses, and then divide by 2. So you get the answer is about 0.97 if you round that to 2 decimals. Again, here's the exact answer. Here's the estimated answer like that. It can be checked in your calculator real easily by just going second ln and then do 2 times the answer because you're doing e to the 2x. So you do 2 times 0.97 like that. And notice when I do that, that gives me pretty close to 7. Okay, like that. All right. How's that look to everybody? Okay. Study it hard. Okay, let's take a break. Come back at 10 after.